Here we go, chapter 4. Oh, that's a good start. We're going to call this chapter. No, it's not. They fixed the app. I got an email telling me they fixed it. The pen lagging. Yep. Okay, we're going to call this chapter 4A. And chapter 4A, we're going to do lessons 4.1 through 4.4. Okay, now let me break those down for you. 4.1 through 4.3 are all going to be about parabolas. We're going to graph parabolas. We're going to do some word problems, parabolas. We're also going to do some scatter plots, but not linear. We're going to do a quadratic scatter plot. Okay? And then 4.4 is something that you did in Algebra 1 probably. And this is called factoring. And it's tough, I know. But you're going to be better at it this time. It's when you take, like something like this, x squared. Let's do plus 5x plus 6. Do you remember doing this? And then you had to make it into two binomials like that. It's the opposite of foiling, right? And you had to go, what times what? 6 adds up to 5. 3 and 2. But they're a lot harder than that. That's like the easiest one. Yes, we're going to do those. You're going to be really good at them, though. We spend a lot of time. Do you guys remember that, or is that totally foreign to you? Yes, the star method or cross method and all that stuff. Yep. Okay. So here we go. But today we're not going to do that. That's not till 4.4. That's not till after we do some parabolas and stuff. When is factoring? That's next block. Next week block. Not this week, okay? This week we have a lot of stuff to do, though. We're going to do 4.1, 4.2, and half of 4.3. All right, so let's do 4.1, Part A today. And we're going to call this quadratic functions. Quadratic functions. So we're sticking with functions. We actually do functions throughout the entire first semester. It's not really till second semester that we get things that aren't functions. But they're still fun, though. All right, 2 parts today. First part, Part A is just a little intro. I'm going to give you some vocab words in a way, like things that I'm going to be talking about, and I need you to know what they are, because when I talk in math language, you need to know it. All right, so first of all, it's stuff that you already know, too. Like, for example, a parabola. We've already done parabolas this year. We did them when we got our parent function, remember, and we shifted them. We're going to go back to that today. So we're going to focus, this entire chapter is all about parabolas. And a parabola is the same thing as it's the graph of a quadratic function. So I might say a quadratic function. I might say the parabola. The parabola is the graph of it. And now you're probably wondering, what is a quadratic function? Well, a quadratic function is going to look like this. Y equals ax squared plus bx plus c. That's a quadratic function, and a is not 0, okay? If a was 0, it can be 1 or 2, negative, a half, whatever. It can be anything as long as it's not 0. If a was 0, we would have a linear function, right? We might even have a constant if a and b were both 0. Now, with this, if your parabola opens up, that means that a is greater than 0. If your parabola, that kind of looks like a face in a way, huh? If your parabola opens down, so sad, a is negative. Someone in my other class said that looks like a tombstone. They're dead. That's sad. Yeah, I know, very morbid. But we knew that already. We've done that before. A is positive, our parabola opens up. A is negative, it opens down. Okay, so that's one form of a parabola. The form that we like to use more often is called vertex form. And we've done vertex form for absolute value graphs. It's the same idea for parabola, for a quadratic function. It looks like this. Y equals a, and that's the same a that you see here, parentheses x minus h squared plus k. All right? And this should look kind of familiar to you because we did this when we did absolute value. Here was the absolute value one. It was a absolute value x minus h plus k. Do you remember that one? Yeah. This is the same thing, except this is a v and this is a u. But everything else is exactly the same. You're going to be shifting the same ways that we do here and we do there. Okay, now with vertex form, from this graph, like let's say here's your parabola. This point right here is the vertex. And if your parabola is in vertex form, the vertex is at the point HK. That's a comma. HK. I hate that. Must erase. HK. All right? And then you also have something else that's special, and that's called the Axis of Symmetry. And the Axis of Symmetry is the imaginary line that you can envision that takes your parabola and splits it right down the middle. Now, would my Axis of Symmetry be this right here? No, not a chance. Would it be maybe this? Is that the Axis of Symmetry? No. You can see what the Axis of Symmetry is, right? The Axis of Symmetry is going to be this line. It goes right through the vertex. The Axis of Symmetry is vertical. Okay, it's not a horizontal line. It's a vertical line that goes through x equals h. And I didn't just come up with h just out of the blue. Guess what? H is the same number here as it is there. Okay? So whatever the x value is in your vertex is going to be the x value. It's going to be the value for your Axis of Symmetry also. All right, what else? Oh, yes, one more thing. What you doing over there? Video. Don't do it. You're going to get way behind. Minimum and maximum. Now, a parabola can either have a minimum or it can have a maximum. It cannot have both, okay? And the minimum or maximum is always going to be the vertex. And so if your graph opens up, and A is positive, then this right here is called the minimum of the graph. That is the minimum. And we always say the minimum is the y-coordinate of the vertex. So your minimum would be k, because that's your vertex is hk. So that's the same, this k right here is the same as this k on your vertex. The vertex is very, very special. What did you ask?
Why do they use HK?
I don't know. That's a really good question. Yeah, they always have HK for all of them. All right, then your maximum would be if your graph opens down. The maximum is that vertex right there. That's the maximum. And it's still the y-coordinate because that's how high it will go. See, x is left and right, right? X is left and right, and y is up and down. So how high does my graph go depends on what y it is. And that would also be the k value. Whew. Are you ready to do some now? Sure. Okay, part B. Part B. Now let's do some graphs. And I'm going to show you how to graph this a few different ways, okay? So, number one, we can graph these using tables. And they might ask you to write a table of values and plot the points, okay? So the first way would be to do tables. So let's do two of those. Number one, we're going to graph f of x equals 1/2 x squared. Okay? I know that's a parabola because I see the x squared in it. X squared tells me it's going to be a U shape. So let's go ahead and take some values in a table. Ooh, I love those. Yes, 0, 1, and 2. But also, let's take -1 and -2. And I know you don't want to do negative numbers, but you need to. Heavy sigh. Okay, So don't forget though, if you're going to do these in your head, make sure you do exponents first and then multiplication. Okay, so 0 goes in and I square 0 times 1/2. Good, 0, 0. There it is. Plot the point 0, 0. All right, 1 goes in. I'm not going to do 1 times 1/2. I'm going to do 1 squared and then times 1/2, which would be 1/2. That's okay. It's kind of ugly, but whatever. So what's that point? 1, 1/2. Yeah, that's right about there. Okay. All right. Now let's plug in 2. Don't do 1/2 times 2. Do 2 squared first, right? You see what we're doing? 2 goes in for x. You square the 2, which is 4. And what's half of 4? 2. So let's plot that point. 2, 2. Oh, do you see how it didn't follow a line? It's not linear. And now let's go ahead and plug in the other ones. When I square -1, I get +1 times 1/2. And when I square -2, I get +4 times 1/2. So I'll go over to -1, and I'll plot -1, 1/2, and -2, 2. My lines are a little off, though, because I went too far with this one. That's going to bother me. Sorry. I'm fixing things here. I should be about here instead. It's like the same spot. Okay, anywho, so I get my parabola that looks like that. Just make the dots bigger. There you go. Nice, huh? And is that symmetric? Yeah, symmetric down the line, y equals 0. Beautiful. All right, let's do one more of those, making a table and graphing it. Number 2. Let's do y equals -3x squared. Negative, yes. So is this parabola going to open up or down? Perfect. You have been listening. All right. We like you to pay attention. You always say such nice words. All right. 0, 1, 2, -1. Let's just use those same numbers again. Those were nice. They worked out really well for us. So let's plug in 0. 0 squared is 0 times -3 is 0. Plug in 1. 1 squared is 1 times -3 is -3. Plug in 2. Square the 2 first. 2 squared is 4 times -3 is -12. And by the way, if you know it's symmetric, no, let's not do that yet. All right, plug in -1. -1 squared is 1 times -3 is -3. And then -2 squared is +4 times -3 is -12. All right, so let's plot the points. I've got 0, 0. I've got 1, 1, 2, -3. By the way, I also have -1, -3. That's going to be its kind of counterpart, you know, on the other side of the axis of symmetry. And then I've got, whoa, -2, -12, or +2, -12, -2, -12. So this is a really skinny graph. It should, man, my dots are off. Maybe it's not my dots, it's like the equation, the graph is off. There we go, that's better. Try and make it as round as you can. I know it's kind of hard sometimes, but it's not a V. This is not absolute value. Okay, these are parabolas. Okay, now the next way that we're going to graph, that's making a table. No one really likes to do that. It's pretty time-consuming, right? And boring. Yeah, we know. All right, the second way is to use shifting. We're going to do our shifts. Now remember our shifts? We always start with our parent function. Our parent function, if you remember from a chapter ago, is y equals x squared. We're going to take that mother function and we're going to shift it. That really bothers people. They always think I'm going to mess up, but I don't. I don't cuss. All right, here we go. We got that, and we got that. So there's our parent function. Okay? And we're going to do two types of shifting. We're going to shift left and right, and we're going to shift up and down. So if we have y equals x minus h squared, we're going to shift 8 units left or right. And if we have y equals x squared plus k, then we will go k up or down. Just like we did with absolute value. But instead of shifting a V shape, we're shifting a U shape now. Okay? So let's do some. Are you ready? Number 3. Let's do g of x equals, I'll just name them random things, it's fine. G of x equals x plus 2 squared. Okay? So we don't need to make a table of values because we're going to take the parent function. We're going to shift that parent function 2 to the left. Yes, I remember. You were good at these. Yes. Okay, so here's our parent function. I'm just going to graph our parent function in yellow. You don't have to graph the parent function, but I just want to see that's what we're starting with. And we're going to take that thing and we're going to shift it 2 to the left. But it's exactly the same graph when you do that. Still up 1 and over 1. It hasn't been stretched or shrank or anything like that. It's still the same graph. Okay? All right, let's do this one now. H of x equals x squared minus 5. Do you see the big difference between these two? This shift was with the x, and then everything's being squared. Don't think you're shifting 4, don't square the 2. People will do that, that's wrong. But this shift, this means you're going 2 to the left. This is not inside with the x, this is on the outside. This tells me to take my parent function x squared and subtract 5 from it. Move 5 down. So 1, 2, 3, 4, 5. Still up 1 and over 1. Nothing's been stretched. And that's what you get. Okay? Now, you get to try one. And I'm going to give you one that has both in it. We'll call it m of x. Don't be scared. M of x equals x minus 2 squared plus 1. You do this one. Do it all by yourself. Let's see. Let's go ahead and graph this. We're going to shift it 2 to the right and 1 up, and that's where my vertex goes. And from here, it's just up 1 and over 1 in each direction. It's your basic parent function, just graph shifted. Yes? Who got that? Woo! Like almost all of you. Okay. And then the last part is like putting everything together, and it's a little bit extra stuff too. This is the stuff that I'm going to make like really important, and you're going to be quizzed on this, okay? So I'm going to give you a function like this. Y equals 3 x minus 4 squared minus 2. And this is going to be a really big problem, okay? Where I'm going to ask you for like 6 things. I'll tell you what I'm going to ask for. I'm going to ask you for the vertex. I'm going to ask you to tell me what the axis of symmetry is. We're going to say whether this is a maximum, whether it has a maximum or a minimum, and what that is. And then this is new. We're going to talk about its domain and its range. And of course, we're going to graph it. Woo! So we worth like 6 points on your next quiz. 6 of them. Yeah, I know, it's a lot. Okay, so some people like to graph or like to say what the vertex is one of 2 ways. Either they just look at it and they can tell what it is just by looking at the equation, because this is in vertex form. You can go ahead and write it right away. Some people can't see it, so they need to do the shifting part. So if I were to find the vertex by shifting, I would start at 0, 0, and I would shift 4 to the right and 2 down. Okay? So my vertex is the point 4, -2. Okay. my axis of symmetry is always going to be a vertical line, and it's going to go through the vertex. So my axis of symmetry will be x equals 4. It's the same number that's in the x spot of my vertex. Okay. Now let's go ahead and graph this parabola. Okay. Here's what you want to do. See that 3 right there? It doesn't work like it did for an absolute value graph, because an absolute value graph is actually linear on both sides, so you can count slope, rise over run. You can't do that here because it's quadratic. You see how a quadratic is not like a line? So what you need to do is you need to pick a point on either side of the vertex, pick an x value, and then plug it in to find the y. Okay? So let's pick x equals 3. Let's take x equals 3, and we're going to plug it in. And if you have a hard time plugging this in for x and doing this in your head, you can actually do this in your calculator if you need to. Okay? You can do this. We're plugging in 3. So it's 3 parentheses, 3 minus 4, close the parentheses, squared. And what was it? Minus 2. You can put the whole string into your calculator just like that. Hit enter, and it'll give you the right number. Okay? I know, that's awesome, right? Aren't you glad you bought that thing? So it gives you the point 3, 1. So let's go ahead and plot the point 3, 1. But guess what else? I would have this point over here because it's symmetric, right? And now I can graph my parabola, because if you have 3 points, you can do a pretty good job at graphing a parabola, because you know it's a U shape, you know where it goes. All right, now let's answer the rest of them. Does this parabola have a maximum or a minimum? Has a minimum, okay? And that minimum value, how low does it go? It goes down to -2. -2. And guess what that is? The y value of the vertex. That's as low as it goes. Now, domain and range, those are going to be a problem for some people. Not domain, because you know what? Domain's the same for every single problem. The domain is going to be, and I write this weird thing, that's a capital R, all real numbers, yes. This R stands for all real numbers. That means anything that's a real number, so all the numbers that you guys know so far, can get plugged in for x. And so a parabola will always have all real numbers. Parabolas that open up or down always have all real numbers as their domain. Now the range are the y values. So let's look on this graph. My y values are nowhere to be seen down here. Do you see how they're not on the graph? My minimum, the smallest y value I have, is -2, and then everything goes up from there. So my range will be all of the y values that are greater than or equal to -2. So if it's a minimum, it's going to be -2 is the smallest and everything's above it. If it's a maximum, it's everything below it. Okay? You see the difference, maximum, minimum? So y is greater than or equal to -2. All right, I've got one more if you need it. Do you feel like you need it, or do you feel like you've had enough and you're done? All right.